Hello everyone. In this video, I am going to demonstrate data transfer using FSK or frequency shift keying modulation technique. So as you can see, this is my setup. I have made some enhancements in this setup as the previous setup was not able to receive the data properly. So I have made some enhancement in this setup and we are testing the data transfer. So as you can see, this is my Arduino Uno. The Arduino Uno is sending data to the modulator and demodulator unit. So as you can see here, in this video, I have reduced the data transfer rate to 300 bits per second. The data transfer rate is now reduced. Before it was 9600 baud, now it is 300 baud. Only 300 baud data transfer rate is now being used. So as you can see here, data transfer is in progress. And here, same like the previous videos, I am using the optical isolator. I am isolating the Arduino Uno data source from the modulator demodulator unit. So as you can see here, this is the modulator unit. I am using the same 555 timer IC here. Here you can see I have made some changes in the frequency. So the frequencies for the logic 0 and logic 1 are now changed in this circuit. So as you can see, after the modulation, the output is sent from the pin number 3 of 555 timer and it is coupled with a coupling capacitor. This is another enhancement in this video. So after the coupling capacitor, I am using the data, I am putting the data to the filter. I am removing the DC components as the filter is struggling with some noise components. That's why I am using this filter here so that the high frequency components, some high frequency components and the DC components can be filtered out. Finally, I am using the same envelope detector. However, the envelope detector is not wired in this layout and the output of the filter is directly fed to the comparator. And after the comparator data, I am feeding the data to the Arduino Uno. As you can see, there is a reception going on. So let us look into the waveforms of the circuit. Then I will show you the circuit diagram. So as you can see, this is the waveform. You can see here, this is the output data. This data is going to the Arduino Uno and here is the FSK data. So let me zoom this waveform. The real data will be visible now after I zoom the waveform. So I am zooming the waveform. You can see now. You can see when the logic is at 1, you can see there is a high frequency component. And when the logic is at 0, when the logic is at 1, this frequency component, the low frequency component is present. And when the logic is at 0, there is high frequency component. This is the modulated signal and this is the signal after demodulation. This is the signal after the demodulation. You can see the data is quite good. If I zoom the data further, you can see when the logic is 1, when the frequency logic is 1, you can see the frequency. This is the low frequency. And when the logic is 0, this is the high frequency. So as you can see, this is the modulation, this is the modulated data and this is the final data. So if I zoom out the waveform, this is the data. Now I am going to show the source data and the received data. So this is the data coming from the Arduino Uno and this is the data after demodulation. So if I zoom both the datas, what I am going to see, let me little zoom out. You can see the datas are exactly same, only the difference is they are 180 degree out of phase. The datas are inverted. Whatever data I am sending from Arduino Uno and whatever data I am receiving at the demodulator, they are inverted. So if I zoom out the data a little more, you can see the data is exactly matching with the time, but the data is inverted. So if I bring both the waveforms close, you can see the data is exactly same, but the data is inverted. So in this video, I have made an enhancement. I have used a capacitor after the 555 timer IC. So I am removing the DC components and after filtration, this is my demodulated data. So the demodulated data is 180 degree out of phase. You can see there is a complete phase difference. So let us look into the circuit diagram quickly. Here is the optical isolator. Data is isolated from Arduino Uno in the modulator demodulator unit. So here you can see I am using 1K resistance, and here is 10K, and here is again 1K. This is the 555 timer IC. The output of the 555 timer IC is fed to this 10 microfarad 63 volt capacitor, and then I am using this low pass filter, RC low pass filter. Output of the low pass filter is fed to this comparator, and this data is fed to Arduino Uno. As you can see here, Arduino Uno is receiving the data. You can see Arduino Uno is receiving the data. So let us look into the software console. At the transmitter end, I am sending alphabet R, and at the receiver end, since the data is complemented, I am not able to get the data. So you can see here the data is not coming. It is actually a complemented data. That's why I am not able to receive it. So in the next video, I am going to write some enhancements in the Arduino code so that proper data can be displayed here. Please watch this next video for the enhanced results. Thanks a lot. Thanks for watching.